Assalamu alaikum dear students. This is your physics class, and today's class we are again going to discuss about what is positive work, what is negative work, and what is zero work. But we are going to discuss positive work, negative work, and zero work on the basis of angle created between force and displacement. That is, what will be the angle created between force and displacement. On the basis of that, we are going to explain how work can be positive, how work can be negative, and how work can be zero. So far, we have understood that W equals to Fs. Actually, this formula works well only when force and displacement are acting in the same direction. That is, they are acting in the same direction, their direction is same. Or even if force and displacement are acting in opposite direction, again this formula will be used. So this formula will be used only when force and displacement have same direction, or when force and displacement are acting in opposite direction. Let us assume that if we are applying force at some angle, how we are going to calculate work done there. This formula will not work there when we are applying force at some angle. For example, if here is a box, and on this box you are applying a force of F at some angle, that is this, like this, and box is moving along horizontal direction. So you are applying force at some angle. So far we have seen that force and displacement was acting in the same direction, or they might act in an opposite direction. So we were using formula, that is W is equal to Fs. But if force and displacement are acting at some angle, this formula will not be used. It will not be valid. So when force is applied at some angle, what formula we are going to be used here? See here. If here is a box, you are applying a force of F at some angle, the box is moving along a horizontal direction, and there is an angle between this force which we have applied and the displacement of the box. So an angle has been created between force and displacement. Let this angle be theta. So we are taking this angle as theta, which is being created between force and displacement. So what we are going to do here, we are going to resolve the force component of force into two components. That is called a resolution of vectors. One is along horizontal direction, that is this thing, along horizontal direction, and another is along vertical direction. So we are resolving component force into two components. One is along horizontal direction, another is along vertical direction. Let us suppose that the angle between these two, force and displacement, be theta. This angle is theta. So actually, if you will see here, the box is moving in the horizontal direction. This thing, horizontal direction. The vertical component has nothing to do with the motion of the box. So which component is responsible for the motion of the box? That is this component, that is along horizontal direction. So this component is taken as F cos theta. F cos theta. And the another component that is along vertical direction, that is taken as f sine theta. So we have resolved the component force into two components. That is, one is along horizontal direction, it is f cos theta, and another is along vertical direction, that is f sine theta. So actually, if you will see here, which component is responsible for the motion of the box? That is this component f cos theta. This component has nothing to do with the motion of the box, because box is moving along the horizontal direction. There is no motion along the vertical direction. So f, the component of force, that is f cos theta, is responsible for the motion of the box. So let us take that formula, that is f equals to fs. So which of the component is responsible for the motion of the box? That is f cos theta. So I am going to take here f cos theta dot s. So what will become my formula? That is, it will become like this, fs cos of theta. So I have derived a formula, that is work is equals to fs cos of theta. Fs cos of theta. So far we have learned this formula only. Today we have learned one more formula, that is f cos of theta. What is this theta? It is the angle between force and displacement. What is theta? Is the angle between force and displacement. So if you are applying force at some angle, we are going to use this formula, that is work equals to fs cos of theta. Work equals to fs cos of theta. You might have seen a roller in playground, and when you have to move this roller, actually you are applying force at some angle. So force is acting at some angle, and the roller is moving along horizontal direction. So there is angle created between force and displacement. So if you want to calculate work done here, you are going to use this formula, that is fs cos of theta. So work done is equals to fs cos of theta. So on the basis of this formula, we are going to explain now what is zero work, what is positive work, and what is negative work. So far in last lecture, we have explained the positive work, negative work, and zero work on the basis of direction of force and displacement. Now we are going to explain what is positive work, what is negative work, and what is zero work on the basis of this formula, that is on the basis of theta. So let us see here. Let us start from positive work. What is positive work? Positive work. So our formula becomes W equals to Fs cos of theta. So what is positive work here? If the theta between force and displacement is acute, that is theta is greater than 0 but less than 90 degree. If the angle between force and displacement is acute, that is it is less than 90, that is more greater than 0, so our work will be positive. How? See here. W equals to Fs cos of theta. Let us take theta as 0 degree. So what will be our work done? See here. W equals to Fs cos of 0 degree. We know that cos of 0 equals to 1. So my work will become W equals to Fs cos of 1, that is cos of 0, that is 1. It will become Fs. So this is positive work. So what is positive work? If the theta created between force and displacement is acute, that is it is less than 90 but greater than 0, then my work will be positive. So we have explained this thing on the basis of theta. If angle created between force and displacement is acute, then our work done will always be positive. Let us discuss now what is negative work. Negative work. Again, I will write here W equals Fs cos of theta. If the theta, that is angle between force and displacement, is obtuse, that is, theta is less than 180 degree, but theta is greater than 90 degree. So what will be work done? It will be negative. Let us see here. Let us assume that my theta is 180 degree. That is, angle between force and displacement is 180. It is like this. If force is acting in the right direction like this, and the displacement is acting in an opposite direction like this, what will be the angle here? It will be 180. Let us calculate work done here. W equals to Fs cos of 180 degree. We know that cos of 180 degree is minus 1. So use this thing here. W equals to Fs cos of 180 is minus 1. It will become minus Fs. So here you can see work done is negative. So if the angle between force and displacement is obtuse, that is it is less than 180 but greater than 90, the work done will always be negative. So we have understood here how work can be negative on the basis of theta. Let us discuss now what is zero work. Zero work. Zero work. So what is zero work? If displacement is perpendicular to the force, if the angle created between force and displacement is 90 degree, that it is perpendicular, or you may write here F is perpendicular to S, that is theta is 90 degree. What will be the work done? It will be 0. How? Let us see here. Again, I am going to use formula, that is W equals to Fs cos of theta. And what is my theta here? It is 90 degree. So I can write here W equals to Fs cos of 90 degree. And we know cos of 90 is 0. So what will be work done? It will be like this. W equals to Fs cos of 90 is 0. So what will be the work done? It will be 0. So what is 0 work? When the angle created between force and displacement is 90, or you may say when force is acting at perpendicular to the object, or you may say when force is acting perpendicular to the displacement produced in the object, then work done will be 0. It's like this. Here is a box, and let us assume that you are applying a force of F in this direction, and the box is moving along this direction. So what is the angle created here? It is 90 degree. It is 90 degree. So what is the work done here? It will be 0. Why so? Because the theta created between force and displacement is 90. So when you do any sort of work where force acts perpendicular to the displacement, Or you may say, when the angle created between force and displacement is 90 degree, your work will be 0. So you have done 0 work. Let us take one example here. Let us see here. Let us assume that here is a coolie and he has load on his head, or he is holding a load with the help of his hand above his head, and he is moving like this in this direction. So actually he is applying force in the upward direction with the help of his hands. So force is acting in the upward direction like this, and the coolie is moving in the horizontal direction, So what is the angle here created? It is 90 degree. So what is the work done here? He has done 0 work. Although the person has used his energy, he may get exhausted by consuming his energy, but still he has done 0 work. Why so? Because what is the angle created here? It is 90 degree. So when any activity or any sort of work you are doing, while you are applying force perpendicular to the direction of displacement, the work done will always be negative. So it means that how work can be 0, how work can be positive, how work can be negative, we can understand this thing on the basis of theta. And theta is the angle created between force and displacement. So we have understood what is 0 work. If angle created between force and displacement is 90 degree, work done will be 0. Even in last lecture we have discussed one thing: if force is 0, work is 0. If displacement is 0, work is 0. If both are missing, there is no force, there is no displacement, again work is 0. If there is force but there is no displacement, again work is 0. If there is force, there is displacement, there is force, there is displacement, again work can be 0. How? On the basis of this theta. Although you have applied force, you are displacing the object, but you might be applying force at an angle of 90. So again your work done will be 0. So I hope you people have understood today's lecture. We will meet next time. Till then, Allah Hafiz, take care.